Hi everyone, welcome to a brief introduction to F Sharp. I'm Erik, and in the next 25 minutes I'll tell you some of F Sharp's history, some of what makes it a great language. We'll do a live coding session showing you some actual F Sharp code, and then in the end we'll recommend you some resources that you can use to learn F Sharp. Hope you're as thrilled as I am, and let's get started. F Sharp is a functional first language that has been developed by Don Syme at Microsoft Research in Cambridge. It's a functional language that runs on the .NET runtime. Its syntax is inspired by OCaml. It's basically a port of OCaml to the .NET platform. It's a general purpose language. You can use it for basically everything. It's not just for a very specific use case. You can build websites with it. You can do apps. You can do backends, whatever. You can do anything you like with F Sharp. It's a compiled and statically typed language, so there are types, and types are pervasive. You have to think about types in your code, but there's also a lot of goodness that comes with that. So the compiler really helps you out with preventing certain types of mistakes, and you can encode a lot of stuff in within the type system that you might otherwise need to check at runtime. As said, it's a functional first language, which means that the preferred way of doing things in F Sharp is to do them functionally, but it's not the only way that you can do things. You can also use F Sharp to program in an imperative or object-oriented way. And in some cases, an object-oriented approach might even be preferable to a functional approach. So what F Sharp recommends is that you try to see if a functional approach could work well, but if it can't, you can just do object-oriented programming. And it's actually a really nice object-oriented language too. Furthermore, F Sharp is a very pragmatic language, and what I mean by that is that it doesn't incorporate all bells and whistles that you could think of. So it doesn't have macros, it doesn't have type classes, and it has shown great restraint in adding new features. So there have been many requests to add features that could be useful for a couple of people, but that might not benefit most people. So what I find really interesting is that F Sharp's benevolent dictator for life, Don Syme, chooses to actively explain his decisions and not include a lot of features that other languages might want to include. There are a lot of reasons why I think F Sharp is a great language. First and foremost, I really like its syntax. It's the one thing that you constantly see. So I really like that F Sharp syntax is clear, it's easy to read, and I really love its syntax. There's also not that much syntax, which is due to the aforementioned restraint in adding new features. So there is not as much syntax to learn that you might need in other languages. It also has it's very expressive, so you can do a lot with little code. There are tons of built-in functions that you can use. It has some very neat built-in data types, including discriminant unions, which are like sum type. Pattern matching is excellent, so you can do a lot with little code. The type system is great too, and that it, for example, has very good type inference. It warns you about possible mistakes that you made, exhaustiveness checks, etc. And there's a lot of built into the compiler's type system where it prevents you from making common mistakes. This also includes immutability, where everything is immutable by default. So it's harder to make a certain type of mistake that you do make with mutable data types. The tooling is, I'd say, one of the best of the functional languages. You can use different IDEs. You can use Visual Studio, which has a free version. You can use VS Code with the Ionide plugin. And you can use JetBrains Writer, which isn't free, but it's also a great F Sharp IDE. All the IDEs have excellent code completion, and they show you type annotation for inferred types, etc. There's just a ton of it going on, and you can do debugging. It all works really well. There is a REPL, so you can use a REPL to interactively work with your code. So I really recommend F Sharp due to its tooling, because I personally really like to work in a good IDE. It's also multi-paradigm, so you can work functionally, of course, and I really like that. But it's also really nice to be able to do object-oriented programming, because for some things, an object-oriented approach just works really well. And then it's good that F# actually gives you that opportunity. This is also very useful if you're starting out with a functional language and you might not be as familiar with the functional paradigm, but you do know object-oriented programming. So then you could start out with doing things in a slightly object-oriented way and then moving on somewhat slowly to replace it with functional code. And that gives you less of a bump to start out with. It also has great interop with the rest of the .NET ecosystem. So you can use any library that has been written in C# or VB. The whole of NuGet is available to you. So there are like millions of packages that you can use, and they all integrate really well. F# has one of its key tenets is that it has to have great interop with the rest. So if there is a new language feature that C# introduces, F# will look if that makes sense for F#, and if so, it will incorporate it too. And if not, it will do something that you can at least work with code that was written using that feature. Its documentation is excellent. There are many resources, but the official ones are brilliant. At the end of this talk, I'll mention a couple of more, because my favorite resource is actually not one officially by Microsoft, but it's from somebody else. But I'll let you know that in the end. And then finally, what I love about F# is its community. There are so many nice people there. It has a really friendly community. They are very open. Discussions are ongoing. The whole compiler is open. So if you want to see a feature added, you just add an RFC in an issue somewhere, and then there will be an open discussion on it. And I always felt really welcome by the F# community. I'd like to explicitly mention some of the standout features that I think make F# an especially great language. First of all, there's active patterns. If you've heard of pattern matching, you'll probably know that you can pattern match on different types of things. You can pattern match on constant values. You can pattern match on lists. You can pattern match on maybe tuples or other stuff. But what active patterns allow you to do is to add your own pattern matching types. So you could, for example, create a pattern matching support for regular expressions, where you specify an expression and then you get back the captured value. So you can go wild with that, and it has the ability to integrate a lot of complex logic very elegantly within pattern matching. So it's a great feature. Another really cool feature is type providers. So what type providers do is it's a compiler plugin where you can point your type provider to an external or a local resource like a JSON file. So the JSON type provider, you can point it to a JSON file, could be on the web, but what the compiler will do is when it sees the type provider, it will generate all the types that are that you can accompany, that reflect the JSON file. And then you can actually do code completion on the JSON file. So if you see this in practice, it's like magic. You point it to a URL with the JSON file, and you get built into the compiler all the types that you need to interact with that JSON file. It really is very cool. Another very cool feature are computation expressions. If you've heard of monads or monoids, etc., this is F#'s take on that. It doesn't have all the fancy mathematical terminology associated with it, but you can think of this as a sequence expression of computation expression is like doing things in sequence that might not actually run in sequence. So an example of this is async code, where you're calling an async thing and you have to wait before it's returned, and then you do the next thing based on the result, etc. So normally you would have something like callbacks or maybe something differently. But with sequence of computation expressions, you can do this sequentially. At least it looks like it's sequentially, but the F# compiler will generate all the necessary plumbing for you, so that even though it looks sequentially, it will actually do the right thing. And there are different options. There's an async one. There's one to build sequences. There are a lot of different computation expressions available. Another thing that's really cool is units of measure. So you might have heard of the NASA Mars rover that crashed because of one team used the metric system and another used the English pounds, inches, etc. So there was a translation mismatch. And if you think of your own code, usually when you write things, they're just integers or floats. You don't know if it's a float that represents meters or if it's a float that represents yards. So with F#, you can annotate numbers with their measures, their units of measure. So you can say, hey, this is 10 meters, and this is 10 inches. And you wouldn't be able to multiply them by default unless you explicitly make that possible. So it prevents all these unit conversion issues that you might have. And you see it used rarely in other languages, but I think it's a really nice feature if you're working in a domain that uses a lot of units. And then this can be a lifesaver. You could save over $100 million, for example. A feature of F# that, if you start out with it, it might be very awkward to work with is dependency order. It means that if you want to use a function, it has to be already defined. So you can, in F# code is being read from top to bottom. So you have to define something first before you can use it. You can't forward or anything like that. This is seen in a couple of other languages, but F# takes it slightly more extreme. This also holds for the actual files. So suppose you have an F# project that uses different files. The files have a specific order. So if the first file is file A and the second file is file B, you can only use things from file B if you have it be already loaded. So file B can use file A, but not the reverse. So you might think this is an awful feature, but it's actually a very good feature because it breaks dependency cycles, and cycles are really, really bad for your code and understanding what your code does. So it might take some getting used to it, but in the end, I really love the feature because it made my code more explicit and it's basically more simple to reason about your code. And I always love that. And then finally, what I find really cool about F# is that there's this thing that's called Fable. And Fable allows you to run your F# code in the browser. So Fable compiles F# code to JavaScript code. And there is a lot of stuff that's built on Fable. So Fable allows you to build websites in an Elm-ish way. So like Elm, where everything that's in the UI is built via functions. So you have a function to create a div, etc. And it's a really cool feature, and I really encourage you to explore it. Enough with all the talking, let's see some code. So for the code, what I want to do is I want to solve the isogram exercise in the F# track. The isogram exercise is about taking a word, it's a string, and then determining whether or not there are no repeating letters. So if you have a string ABC, that word is an isogram because the A and the B and the C only occur once. If the string is AABB, it's not an isogram because A occurs twice and B occurs twice. So let's see if we can implement that logic in F#. So first, let's start out by running all the tests and see they shouldn't all pass, and they don't. We get some tests passing, but that's coincidental. So let's start and see how we solve this. So the first thing that we need to do is we need to get all the letters from a string. And in C#, a string is a sequence of characters. So what we want to do is we want to take that sequence, but only extract the letters from it. So for that, we can use the sequence module. And that sequence module has a lot of functions. So there are really a lot. But the one that we are looking for is filter. So filter says it takes in a sequence, and you pass it a predicate, which takes in an element of the sequence and returns a Boolean. If that Boolean is true, the element will be in the resulting sequence, and if it's not, it's discarded. So this is a way of filtering things from a sequence, and then it returns a new sequence. So it doesn't modify the existing one, it returns a new thing. So let's start out with the predicate. In F# you can either define a separate function or define a lambda, which is like a tiny function that you directly specify within your code. So let's do that. So we're going to take the fun keyword, and this is the name of the thing that gets passed in, which in our case is a character. So let's be explicit, character. And then we need to check if this is a letter. The best way to do this is by reusing something that's built into the .NET framework. So for that, we need to open system namespace, and the system namespace is something that is built into the .NET framework. So you use this from C# too. And then we can do har.isLetter, which is the built-in method that you can use to test if a character is a letter. We're passing our character argument. And then the only thing that we need to do is we pass in the source of the sequence, so the sequence, which is our word. And as I said, word is a sequence of characters, so this works. The reason why this complains is we haven't yet assigned this to a value. So assign this to letters. And now letters only contains the characters. So it's a sequence of har, which means that it's only characters, but they are all letters. Then how do we determine whether or not there are duplicates? Well, we can try and find the unique letters and see if the length of the number of the unique letter sequence is equal to the letters. We'll explain that in a minute. First, let's see how will we get the unique letters. Well, there is a function for that. So it's called distinct. So we have seg.distinct, and we call that with letters, and this will return all the unique letters. So any duplicates are removed by seg.distinct. Then finally, we can check if it's an isogram, if the number of the elements within the unique letters is equal to letters. So if it is an isogram, there are no duplicates, which means that the removing of the duplicates doesn't really do anything. So the length stays the same. So if the length of letters is equal to the length of unique letters, no duplicates were removed, and means everything must be unique, and it's an isogram. So let's run this. Oh, we pass almost all the tests. So there are two tests that fail, and they're both having to do with mixed case, so casing. And this is because if the input has a capital A and a lowercase a, that should count as a duplicate, but we haven't yet accounted for this fact. So what we need to do is we need to call a method on the word, which is toLower. And you can see here that F# integrates with the object-oriented way in which the .NET Framework works. So in the .NET Framework, a string is an object, and to get its lowercase version, you call a method on the string object. So we're doing that. There are some functions that F# has created functional versions of. So you could do let to lower, and then do a string, and then call to lower, which is possible. So that will be like a functional wrapper. But the official guidelines for F# tell you just use the built-in method. And this shows you that F# isn't as principled as some other language might be. So it's fine to use object-oriented features in your functional code. Let's run this again. It should now all work. And it does. So you might notice that there's this squiggly here, and it says lambda can be replaced with har.isLetter. And let's make a duplicate of this line, and then we'll use the IDE. So you can see here that the IDE integration is really good. It even suggests doing a transformation on the source code. So I'm going to apply this, and it has changed this line to this line. So if you have a function that takes a single argument and you pass it to another function or method, then you can just omit all the boilerplate fun thingies, and the compiler will figure it out for you. So these two lines are both the same thing. So if we remove this, everything still works. But the main thing that I wanted to show you is that the IDE gave you the suggestion of doing this. And Visual Studio will do the same thing. I'm guessing Visual Studio Code will also do it. But it's a neat way of making the code even more concise. So I would argue that this is very readable. But let's try out one other approach, which is to use a list comprehension. So what that means is if you come from a Python background, you'll probably be very familiar with this type of thing, where you can build like a sequence with a very nice and elegant syntax. What we do is we can do curly brackets, and we say for character in word dot to lower, do if the hard dot is letter characters, then will yield character. So this is a different way of writing what we just wrote. Whichever version you prefer is fine. Some people really like this version, others like the other one. I'm okay with both. They're both expressive and clear. It's just a different way of doing things, but this shows you that F# does have some syntactic sugar, but it's not a lot. So let's run it again. And it still works. So we have here what I would argue is a very nice and concise and somewhat elegant solution to the problem. And then finally, I'd like to point to some resources that you can use to learn F#. Of course, I have to mention the F# track on Exercism. It is a very large track. It has 132 exercises, and about 13 of those are learning mode exercises. So you can take your first steps into F# via F# track's learning mode, which we highly recommend, because then you slowly build up your functional F# skills. Apart from that, a very, very good resource, and it's actually one of my favorite resources ever regarding programming, is the F# for Fun and Profit website. We'll put links in the YouTube description, so don't worry about that. But it's a website that covers almost everything related to F#, but not only on F#, it also writes things for people that are just starting out with functional programming. So you can learn to think functionally. So that's what I have here on this page, the Thinking Functionally series. And there's a whole lot of concepts here that are explained that you probably need to know as a functional programmer, but they introduce it in a way where your actual learning is fun. So it's a very pleasant way of things being written. There's tons of other goodness like railway-oriented programming, which is awesome, property-based testing, etc. There's so much goodness here. There's a monad explanation series that uses Frankenstein. It's crazy, but it really works well. So I highly recommend, if you want to try out F#, to use the F# for Fun and Profit website to augment your learning. I'd be remiss not to name the official documentation pages, the official Microsoft documentation. It has been greatly tweaked over the last couple of years, but it's now in a state where I think it's really good. So there are guides to start out with, I don't know, Visual Studio, Visual Studio Code, but also how to install F#. There are language guides. There are guides for different types of workloads, so do web development or whatever. And of course, there's an API reference with all the functions that you can use, and there are a lot of functions because it's a functional language. So a lot of functions that you can use with great examples, etc. So I really like the documentation on the official pages. And then there's this series on YouTube. It's called F# for Beginners. And all the videos are between a couple of minutes to 10 minutes long. And they explain one or two concepts in a very neat and orderly way. So this is also, if you like to learn stuff by watching videos, I highly recommend watching this series. And then the final resource is this book. It's Stylish F# by Kit Easton. And it's a really good book, and it teaches you how to think like an F# programmer, all while showing you how elegant F# code can help you with that. And I'm actually giving away this specific book. So if you're interested in this book, complete and publish 5 F# exercises during Functional February, send me a message on maybe on YouTube or whatever. Put it in the comments. It's probably the easiest way. And then in the end, I'll randomly draw one of the winners and I'll send you the book. So if you want to have a free book, apply. I hope this has been a useful introduction to F# and you're inspired to give it a try. Thanks for watching.